Here is another example of a pair. Remember, hypotheses come in pair, of a pair of hypotheses. All right, I'll read it and then I'll show it. And then we'll talk about it in the same manner that we just talked about the UMKC athlete one. H sub 1, research hypothesis, H sub 1. Facebook users are of a significantly different age than the general population, which is 58 years old. All right, once again, Facebook users are of a significantly different age than the general population, which is 58 years old. That's our research hypothesis. Facebook users are of a significantly different age than the average, than the general population, which is 58 years old. So let's talk about what that hypothesis is telling us. It's telling us that we need to take a sample. In this case, the sample is a sample of Facebook users, right? That's a subgroup of the entire population, Facebook users. So we need to take a sample, Facebook users, calculate their average age, their mean age, and compare their mean age to what we think is the parameter, the true population age. Now, another thing I want to point out is, does this hypothesis say that Facebook users will be significantly older than the general population? No. Does this hypothesis say that Facebook users will be significantly younger than the general population? No. It simply says that Facebook users are significantly different. So, like the example before with UMKC athletes, that means we are open to finding three outcomes. If we had data to test this, we're open to finding that Facebook users have the same age, are of equal age to the general pop. We are open to finding that Facebook users are significantly older than the general pop, and we are open to finding that Facebook users are significantly younger than the general pop. Once again, as a reminder, and this is a very important concept, and that's why I am trying to emphasize it in great detail. Again, I didn't simply say, this hypothesis doesn't simply say different. This hypothesis says significantly different, and that's a very important detail to keep in mind. Why didn't I just say different? I didn't just say different because we're talking about comparing a sample to a population. Anytime we have a sample, we're going to have error. And anytime we have a sample which has error, that sample is going to be different from the general population. But what we want to know, or what we want to do with our hypothesis testing, is to determine if the differences are significant, statistically significant. And what that means to say that something is significantly different is to say that the difference, this is so important, that the difference is so large, that we cannot attribute it to sampling error alone. There is something else going on there. Maybe it's the fact that they are Facebook users and everything that comes with that. We don't know. But think about that. That's a very important concept to keep in mind. Anytime we have a sample, we have error, which means our statistics, in this case our mean, is going to simply differ from an assumed parameter. But what we want to know through the process of hypothesis testing is whether or not that difference is so large that we cannot reasonably attribute it to chance or sampling error or accident alone. That's what we're testing. Once again, we're testing whether or not the difference between a mean and an assumed parameter is so large that we can't reasonably attribute the difference to sampling error or chance or accident alone. We're testing whether or not we can reasonably attribute that difference to chance or sampling error or accident alone. Here's another example. I think. Yes. I'll read it. Oh, I'm sorry. Facebook, the null hypothesis, H sub 0, the one that we're actually going to test, so I should mention that one as well. Here it is. Facebook users are of the same or equal age as the general population of 58 years old. Facebook users are of the same or equal age as the general population of 58 years old. That's our null hypothesis, and guess what? That's the one that we're testing. Facebook users are of the same or equal age. So when we actually put the rubber to the road, so to speak, and start doing some math and setting up these problems and actually doing hypothesis testing, we would need to make a decision. Do we accept that null hypothesis or do we reject it? Well, we'll find out. Here's a third set of hypotheses. H sub 1, research hypothesis. Commercial pilots develop heart problems at a significantly different rate than the general population at 21%. Once again, commercial pilots develop heart problems at a significantly different rate than the general population. What's this hypothesis stating? Well, it's telling us to take a sample, commercial pilots, calculate their mean, their average heart rate problems, and compare it to the general population, which has been assumed or presented to you as being 21%. So note, I didn't say different because commercial pilots represent a sample. Commercial pilots represent a subgroup of the population. I had to say significantly different because I want to know that if commercial pilots do differ from the population in terms of the rate at which they develop heart problems, if that difference is so large that I can't reasonably attribute it to chance alone. The null hypothesis: commercial pilots develop heart problems at the same or equal rate as the general population at 21%. Again, whoops. Sorry. Commercial pilots develop heart problems at the same or equal rate as the general population at 21%. So again, think about what we're saying here, or what are we open to finding? Once again, we are open to finding that commercial pilots are the same as the general population regarding heart rate development, that they are significant, that they develop heart rate problems at a significantly lower rate than the general population, or that they develop heart rate problems at a significantly higher rate. So commercial pilots develop heart problems at a significantly different rate than the general population. I need to take a sample of information, a sample of commercial pilots, calculate their average heart rate, and then compare that to the general population. Once again, am I saying that commercial pilots will develop heart rate problems at a significantly higher rate? No. Am I saying that commercial pilots will develop heart rate problems at a significantly lower rate? No. I'm simply saying that commercial pilots are going to develop heart rate problems at a significantly different rate, which means as a researcher, as an objective researcher, I'm open to finding three possible outcomes depending on my data and depending on my conclusions. And those three possible outcomes are that commercial pilots are the same, statistically the same as the general population. I'm open to finding that commercial pilots develop heart rate problems at a significantly lower rate. I'm also open to finding that commercial pilots develop heart problems at a significantly higher rate.